By 1943, Nazi Germany was losing the war it had started on its own terms. The Wehrmacht no longer held the initiative on any front. Allied bombers were reaching deeper into German industry every month, and the manpower and material advantages of the Soviet Union, the United States, and Britain were becoming impossible to offset through conventional means. Faced with this shrinking margin, the Third Reich turned increasingly toward a different kind of solution, technology that promised to substitute engineering ingenuity for the divisions, aircraft, and industrial capacity Germany no longer had. This produced a wave of programs that ranged from genuinely revolutionary to nearly unworkable. Some, like ballistic and cruise missiles, previewed the shape of post-war warfare decades early. Others, like continent-spanning artillery pieces and 1,000-ton tanks, revealed a strategic culture increasingly detached from what its factories, fuel supplies, and railways could actually deliver. This documentary examines the most unusual weapons to emerge from that period, how they worked, what problem each was meant to solve, and why so few of them changed the outcome they were built to influence. Germany's most consequential secret weapons were not radical in individual technology so much as in category. They were the first weapons designed to strike an enemy homeland without a pilot or a soldier anywhere near the target. V-1 flying bomb. The Fieseler Phi-103, better known as the V-1, was a pulse jet-powered cruise missile that entered service in mid-1944, primarily targeting London and Antwerp. It flew a preset course using a simple gyroscopic autopilot, with an airlog device counting propeller rotations to trigger its dive once it reached a preset distance. Its low-cost and simple pulse jet engine made it producible in large numbers, but its predictable flight path meant fighters, anti-aircraft guns, and barrage balloons could intercept a significant share before they reached their targets. V-2 ballistic missile, the A-4, designated the V-2 for propaganda purposes, was the world's first operational long-range ballistic missile, developed under Wernher von Braun at Peenemünde. It carried roughly a 1-ton warhead on a suborbital trajectory reaching altitudes above 80 kilometers, striking its target at supersonic speed with no warning and no effective countermeasure available to the Allies. Its guidance was accurate only to within a few kilometers, which limited it to area bombardment of cities like London and Antwerp rather than precision strikes, and each missile consumed resources and skilled labor far out of proportion to the damage it inflicted. V-3 Supergun, the Hochdruckpumpe, or V-3, abandoned rockets altogether in favor of an enormous multi-charge cannon, using a series of staged propellant charges along a barrel roughly 150 meters long, to progressively accelerate a shell toward London from installations in northern France. The concept promised sustained bombardment at a fraction of the cost of a V-2 launch, but the project was crippled by Allied bombing of its main site at Mimoyex before it ever fired operationally against its intended target, and a scaled-down version saw only limited combat use against Luxembourg. Rockets and superguns solved the problem of range. A separate set of programs tried to solve the much harder problem of accuracy. For the war, precision at long range meant a well-trained bombardier and a stable bomb sight. Germany's guided weapons programs tried to put the guidance system in the weapon itself. Fritz X. The Fritz X was a radio-guided armor-piercing bomb, dropped from high altitude and steered by a bombardier tracking flares on its tail fins. It achieved its most notable result in September 1943, when it struck and sank the Italian battleship Roma as the fleet attempted to defect to the Allies, demonstrating that a guided weapon could destroy a heavily armored warship in a single hit. Its usefulness declined once Allied forces developed radio jamming countermeasures, and once German bombers carrying it became easier targets for fighter defenses. Henschel Heisch 293, the Heisch 293, was a rocket-boosted, radio-guided glide bomb designed against unarmored or lightly armored ships, such as destroyers and transports, first used operationally in the Bay of Biscay in 1943. Unlike the armor-piercing Fritz X, it carried a conventional high-explosive warhead intended to achieve effect through blast rather than penetration, and it forced Allied convoys to adopt new radio jamming and evasive tactics specifically to counter it. Both guided bombs represented a genuine step toward the precision-guided munitions that would define naval warfare decades later, but their reliance on a bomber holding a straight, low-altitude course during guidance made the launch aircraft dangerously exposed. Guided weapons extended Germany's reach against distant or hardened targets. On the ground, a different set of problems called for a return to something closer to brute force. Where rockets and guided bombs represented forward-looking technology, some German programs solved battlefield problems with a much older idea: overwhelming size and mass. Karl-Gerät. The Karl-Gerät, also known as the Mirza Karl, was a self-propelled siege mortar firing a shell of roughly 600 mm caliber, built specifically to reduce hardened fortifications such as the Maginot Line, and later used at Sevastopol and during the Warsaw Uprising. Each of the small number built weighed over 120 tons, and required extensive rail and road support simply to reposition, making it one of the least mobile weapons ever fielded, despite technically being self-propelled. It represented genuine engineering achievement in solving a specific siege problem, but its logistical footprint meant only a handful were ever built or usefully deployed. Sturmtiger. The Sturmtiger mounted a massive 380 mm rocket-propelled mortar, originally a naval depth-charge launcher on a Tiger I chassis to demolish fortified urban positions at short range. It carried only a handful of the enormous rounds it fired, and its heavy, slow-loading launcher made it best suited to defensive, close-range urban combat such as the fighting during the Warsaw Uprising, rather than open maneuver warfare. Fewer than 20 were built, reflecting both the complexity of adapting a naval weapon to a tank chassis and the narrow tactical niche it filled. Goliath tracked mine. The Goliath was a small, remote-controlled tracked vehicle carrying an explosive charge, steered by cable to a target such as a bunker, bridge, or armored vehicle before being detonated. Its slow speed, exposed control cable, and thin armor made it vulnerable to small arms fire before it reached its objective, limiting its battlefield effectiveness even though several thousand were produced. It stands as one of the earliest combat deployments of a remotely operated ground vehicle, a concept that would not mature into a practical weapon system until decades later. Heavy ordnance addressed fixed defenses. For the individual infantryman, German designers pursued a very different kind of unconventional solution. Not every unusual weapon program required a factory the size of a city. Some of the strangest ideas were meant to fit in a single soldier's hands. Take the Krummlauf. It was a curved barrel attachment for the St. Chief 44 assault rifle, designed to let a soldier fire around a corner or from inside a tank without exposing themselves to return fire. Versions were built with bends of 30, 45, and even 90 degrees, though the curvature caused rapid barrel wear and reduced the round's velocity and accuracy the sharper the bend became. It saw only limited field use, mostly the 30-degree infantry version, and functioned better as a proof of concept than as a reliable combat tool. Then there was the Fliegerfaust. This was a shoulder-fired, multi-barreled rocket launcher intended to give infantry a man-portable weapon against low-flying Allied aircraft, firing a salvo of small rockets in a spread pattern to improve the odds of a hit against a fast-moving target. Its short effective range and the difficulty of aiming rockets against aircraft speed meant it achieved little practical success, and it reached troops only in the war's final months in very small numbers. It nonetheless anticipated the man-portable anti-aircraft missile systems that would become standard equipment decades later. Infantry weapons tried to compensate for a shrinking, less well-equipped army. In the air, one final program pursued a solution to a threat no gun could reach. This led to the Ba 349 Natter. It was a vertically launched, rocket-powered point defense interceptor, designed as a near-disposable weapon that could be built quickly and cheaply from mostly wooden components to counter Allied bomber formations. It launched straight up from a vertical rail using solid fuel boosters, fired a single volley of unguided rockets at a bomber formation, and then had its pilot and rocket engine descend separately by parachute for reuse. Its only manned test flight, in early 1945, ended in the pilot's death, and the program was abandoned before it saw operational combat, though it foreshadowed the vertical launch interceptor concepts explored by several air forces after the war. Taken individually, several of these programs represented real technical achievement. The V-2 was the first weapon to leave the atmosphere. The Fritz X and H's 293 were the first operational precision-guided munitions. The Ba 349 anticipated a category of aircraft that would not mature for another decade. Judged purely as engineering, German secret weapons research produced several genuine firsts. Judged as wartime policy, the picture is far less favorable. Each of these programs consumed skilled labor, raw materials, and industrial capacity that Germany could not spare by the middle of the war. The V-2 program alone diverted enormous resources toward a weapon whose inaccuracy limited it to terrorizing civilian populations rather than achieving decisive military effect at a cost per unit that dwarfed the damage it caused. Programs like the Karl-Gerät and Sturmtiger solved narrow tactical problems while demanding rail and road support that an already strained transportation network could barely provide. two projects never came close to seeing action at all. Consider the land cruiser P-1000 Rada. It was a proposed land cruiser conceived at roughly 1,000 tons, armed with naval-caliber guns taken from a battleship turret that never advanced past paper design studies. Its projected weight would have made it too heavy for nearly any bridge in Europe and impossible to transport by rail, and the project was cancelled in 1943 as an unworkable diversion of resources needed elsewhere. Another was the Silbervogel, or Silver Bird. This was a theoretical suborbital rocket bomber concept developed by engineer Eugen Senger, intended to skip along the upper atmosphere and strike targets as distant as the United States before gliding back to a landing. It never progressed beyond design studies and calculations, but its skip-glide trajectory concept directly influenced post-war American and Soviet research into boost-glide vehicles. These two projects illustrate the underlying pattern most clearly. By the war's final years, German military planning increasingly favored ambitious technical solutions over the unglamorous work of sustaining existing production, training replacement crews, and keeping fuel flowing to the front. The regime's secret weapons programs promised to reverse the war through innovation. In practice, they mostly consumed resources that a collapsing war economy could not replace. None of Germany's unconventional weapons reversed the course of the war, and several never fired a shot in anger. What they reveal instead is what a modern industrial state does when conventional strength runs out. It gambles on technology to buy back an advantage that manpower and material can no longer provide. Some of those gambles, the ballistic missile, the guided bomb, the rocket interceptor, quietly defined the shape of warfare for the rest of the century. Others were monuments to a war effort that had begun mistaking ambition for strategy. Germany's secret weapons did not win the war they were built for. Many of them helped write the opening chapter of the one that came after it.